Unit 8, Angle Relationships, Lesson 4, Mixed Angle Relationships. So today we're going to be putting together the pieces that we have already done. So vertical angles, linear pairs, alternate interior, alternate exterior, consecutive interior, consecutive exterior, all kind of in a mixed bag. So there'll be diagrams with angles all over the place, and we got to figure out how they are related to one another. So I want to remind you, first of all, that in most cases, there are really only two possibilities for your angles, unless, sometimes we have like that 90-degree mark or whatever where we're going to use the angle addition postulate. But for the most part, most of your angles are going to be related in two ways. One of them would be these three, and that would be that they're congruent to one another. Vertical angles we know are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. The other possibility is that you might have angles that are supplementary or add to 180 degrees. Your linear pairs are going to add up to 180, your consecutive interiors and your consecutive exteriors are all going to add up to 180 degrees. So let's just dig right in. We're just going to have a few examples here. Find the value of the variable. So hopefully it's visible to you that angle B right here is made by this line. So if I follow that out the other direction, I'm getting that side right there. And then this angle is the other side, or this line is the other side to B. Follow it out. It's this side right here. So 46 and B are vertical angle partners, which means that B has to be 46 degrees. You'll notice I did use a degree sign this time because the variable B did not have a degree sign in the original diagram. Taking a look at this one, we can see that angle E up here is 60 degrees, and this that's marked as X, we don't know what that is. That's what we're trying to figure out. Now, angle E and this angle marked as X are not actually directly related to one another. One's exterior and one is interior, so there's no direct relationship. However, I do know that angle E and this one right here would be 60. This one right here where the O is at would be 60, and this one would be 60. Because remember, 4 of the angles in the diagram are all the same. So this X is not one of the 60s. Therefore, it has to be the opposite relationship. They have to add to 180. So if I do 180 minus 60, I get 120. So X would measure 120 degrees. Taking a look at this diagram, we want to find all of the missing angle measures. So if I look at angle 1, since that's the first number, the only thing that's marked there is a 68 degrees and a 90-degree angle box right here. So 68 degrees is this angle. If I go that horizontal line right here, 1 and 68 degrees are going to have to add up to be 180 because they are a linear pair. So if we do 180 minus 68, we find out the measure of angle 1 is 112 degrees. There's no angle 2, so let's move on to angle 3. Angle 3 right here is a vertical angle with the 68 degree angle that's marked there. So we know they're going to be congruent, so therefore angle 3 has to measure 68 degrees. Now angle 4 gets a little bit tricky, but we know this angle, and I don't really know if that's an S or a 5, but we know that this angle, this box, means 90 degrees. So this either angle S or angle 5 equals 90 degrees. Well, that tells me that over here, 3 and 4 are also going to have to make a 90-degree angle together. So we'll use our angle addition postulate to say 68 from right here and angle 4 have to add up to 90. So if we do 90 minus 68, we end up with the measure of angle 4 as 22 degrees. When two angles add to 90 degrees, they have a special name. They are called complementary. Remember, 180 was supplementary, and then if they happen to add up to 90, that's called complementary. Those are terms that you learned back in middle school. You'll use them periodically. Sometimes they'll show up on standardized testing saying the angles are complementary or supplementary, but usually the supplementary, you can see the straight line. And usually the complementary ones will have a 90-degree marking in the diagram somewhere. The marked angles in this case, 2x plus 10 and x plus 5, they're both inside of the parallel lines, and they're both on the right-hand side, so that makes them consecutive interior angles, and consecutive interiors add up to 180. So we're going to add those two up, so x plus 5 plus 2x plus 10 equals 180. Collect our like terms, x plus 2x is 3x. 5 and 10 give us 15. Then we'll start solving. Subtract our 15, divide by our 3, and we get x to be 55. Notice I did not use degrees because the degree sign is already in the diagram. And then this one, if you take a look at what we have marked, 3x minus 33 and 2x plus 26, they are outside of the parallel lines. A and B are our parallel lines here. So these are exterior. One is below and one is above, so they are on alternate sides, so alternate exterior angles. That means they're congruent. So 3x minus 33 has to have the same measure or be equal to 2x plus 26. That's where I got this line. Collecting our like terms, they're on different sides of the equal sign, so we need to do the different action to one of them. I chose the 2x, so I subtracted it. 3x minus 2x is just 1x. Bring down the minus 33 equal sign and the 26. Add our 33, and we get x to have a value of 59. Once again, I did not include the degree sign because there's already a degree sign in the diagram, so I don't need to add that in there. And that's basically what you're going to be looking at today. So keep in mind, most of the time, the angles you are trying to find, or the angle that you are trying to find, will be related to some measure that's given to you in one of two ways. Either they are congruent, or they're going to add to 180. That's typically the two ways your angles will be related to one another. So take a look at it. Does it have one of the congruent relationships, vertical, alternate interior, alternate exterior? Or does it have one of the supplementary add to 180 relationships, linear pairs, consecutive interior, consecutive exterior? So take a look at your diagrams as you're working today, see how they relate to one another, and then use that to answer your question.